Hello and welcome. My name is Rebekah and I am a candidate for Adventure Freedivers. I am a trainee instructor, and today we're going to look at the urinary system and also the spleen and its response in freediving. This is actually one of my favorite topics to talk about because I find it super interesting and amazing the adaptations that our body can create that help us in freediving, but also in life as well. So strap in. And I'm going to share my screen with you. It's going to make my screen a little bit bigger. There we go. We got it. All right. So the urinary system. So today, as I just said, we're going to discuss the urinary system and its role in the body, the impact that freediving has on the urinary system, and also the long and short-term adaptations that are created through the urinary system and the spleen through freediving. So the urinary system is essentially made up of the kidneys, the ureters, the bladder, and the urethra. So these are our two kidneys. So if we come down here a little bit further, we've got our bladder and our urethra. So the urinary system is also known as the renal system, and it's responsible for filtering the waste products through the blood. It's responsible for regulating blood volume and pressure. It's responsible for controlling levels of electrolytes, and it's also responsible for maintaining the pH balance of our bodily fluids. So it's a pretty busy little guy, pretty important and essential for hydration. So let's look into each one of these aspects individually. So the kidneys role in filtration. So what happens here is as we eat and we drink things within our body absorbs these things through the gut and into the blood, and it circulates the blood in through the kidneys. And the kidneys work to filtrate these kinds of things, and they get rid of what we don't need and they actually keep what we do and start to recycle those things. And the things that we no longer need, that no longer serve us, are excreted through the form of urea, through our urine. So another role of the kidneys is electrolyte balance. So as you're probably aware, 60%, up to 60% of the human body is made up of water. And so the changes in hydration in our body are going to affect our body's blood viscosity. So if we're dehydrated, that means our blood's going to become a little bit more thicker and stickier, which is also going to change our blood pressure. So one of the key roles in the kidneys is the control of electrolyte balance. So what happens is if the kidneys sense that the body is more hydrated or less hydrated, then the body is going to change the electrolyte balance through salt to be able to excrete more fluid if it thinks, wow, there's too much fluid here, or it's going to hold on to fluid if it feels like you are dehydrated. And it's in this way that your kidneys help to control blood pressure. So as I just said, the viscosity of your blood is going to change the way that your heart pumps. So if you've got blood that's super sticky and you're kind of dehydrated, the heart's got to beat harder to be able to push that blood around. Kind of like the difference between pushing mud and pushing water. Yeah. The kidneys also help to regulate blood pressure by controlling the constriction and the dilation of the blood vessels. So if your body senses that the hydration is out and it needs to kind of balance that, it's going to open or close the blood vessels that are going to help to control your blood pressure, how fast and hard your heart needs to beat to push these nutrients around. So another cool job that your kidneys do is it's responsible for the stimulation of the hormonal production of EPO. And this helps to stimulate red blood cell production in the bone marrow. Kidneys are pretty cool, aren't they? So what happens and what's the effect of the urinary system in freediving? So when we dive down deeper, as we know, the water pressure increases as we get deeper. And so this increased pressure compresses the body's tissues, including the blood vessels, and it forces blood from the extremities, from our arms and our legs, towards the central part of our body. This is known as part of the mammalian dive reflex. And as a result, the blood volume in the chest and abdomen increases, or the blood volume in the limbs decreases. And so your urinary system, your kidneys sense this, and they're going to help to control that homeostasis. So they play a role in regulating the blood volume and blood pressure through filtrating this and through reabsorbing and excreting. And this helps to maintain balance in the body. And this can be one of the reasons when you're diving that you feel like you've got to pee often, because your body senses that, whoa, there's lots of fluid here, and it's going to try and get rid of that by peeing. So this is why, as a freediver, it's really essential that we keep up our hydration as we go. So let's have a little look into the mammalian dive reflex. This is super interesting. The body is really amazing. So what happens when we dive down, or when we're even submerged in water? This can happen even just by like putting water on your face. This activates the mammalian dive reflex. So as we dive, or as we feel this pressure, our heart rate decreases. Now, what is happening? We get a blood shift, right? So, gosh, when the kind of science first started to begin around freediving, they thought that if you dive down deep, that your lungs would just pop, that explode. It couldn't absolutely be possible. And they've obviously proved this wrong. They were like, oh, 20 meters, now your lungs are gone. 30 meters, now your lungs are gone. And as we've progressively gone deeper, we've got more and more research around how this is actually possible. So through this blood shift that happens, this is what can help to kind of support the lungs as we go down. So we do get a blood shift. And so what happens is, as we go down, as the pressure increases, as we just said, the blood volume starts to go more to the core of the body. And if we have a look at these pictures here, right, so we've got here, as the blood goes into the core, the pressure or the volume of air is decreasing in our lungs. And what happens to compensate this, so the lungs don't kind of compress too much, is that we've got this fluid, this blood that kind of comes up into the lungs, and that helps to buffer that. Yep, so that's part of this dive reflex that helps us to dive down deeper. So as we are going down, this blood shift helps us to go down deeper, but we're also looking at the kidneys are always working to help to regulate the system through excretion, through electrolyte balances, to be able to bring everything back into balance. All right, so something super cool. And this is a completely different organ. So we're going to talk a little bit about your spleen and what happens in freediving. So your spleen is an organ within your body, if you haven't heard of it, and it's responsible, it's a major part of our immune system, and it's also a reservoir for our red blood cells. So I think of our spleen, which is right here, kind of like a giant sponge, which holds a whole heap of red blood cells. And what happens as a result of low oxygen within the body, it comes to the rescue and it goes, you know what, I can sense this low oxygen. What I'm going to do is I'm going to squeeze out these extra red blood cells when your oxygen is low to be able to increase the oxygen production within the body. Pretty amazing. So this helps to deliver and enhance oxygen delivery to vital organs as part of apnea. And we can actually see through blood tests that it does temporarily increase the amount of hematocrits within the blood, which is pretty cool. It's been shown that over repetition, so when divers do this a lot, can actually increase the size of the spleen, which is going to increase the volume of red blood cell production that it can do. Pretty cool. So that's the short-term effects of diving. So we've got this amazing like splenic contraction that we get these extra red blood cells that helps us to hold our breath for longer. But long-term, I think this is where the really cool stuff happens. So the kidneys play a crucial role in the production of EPO, and that's a hormone that stimulates red blood cells in the bone marrow. So what happens is when we hold our breath, we get this splenic contraction, and this talks to the kidneys. And then the kidneys go, okay, there's not a lot of oxygen here. We're going to have to get better at producing more oxygen because I think we're going to do this again. And so what happens is it stimulates the gene, upregulates the gene of EPO, and then this stimulates the production of EPO. And this EPO then goes onto the bone marrow, which then makes additional red blood cells. And this takes a couple of days. So the long-term effects of this is that when we hold our breath, we get this splenic contraction, creates this cascade of hormones producing EPO, more red blood cells. So then the long-term effect is that we actually have more red blood cells. We have more oxygen carrying capacity. So this is going to improve our endurance long-term and our blood building capacity. Pretty cool. So in summary, our urinary system in freediving helps to maintain homeostasis or balance with blood pressure and with fluid balance. So it helps to maintain our hydration. It helps to support the body through long-term adaptation for improved oxygen carrying capacity. So I think the urinary system and the spleen is one of the coolest systems in the body when it comes to freediving. So I hope I've tweaked your interest in this and given you a little bit of an insight of how amazing your body is when you're diving down and all the cool things that are happening just when you hold your breath and you go down to the water.